In this video, I'm going to talk to you about how to find the domain of a function if you're given the equation. So basically, you want to think of the domain of a function as all of the x values that when you plug it into a function is going to give you a valid output for your y. An example of a valid output would be any sort of real number. So the things that you're trying to avoid are going to be things like if you ended up with like 2 divided by 0. Anytime you end up with a divide by 0 in a function, that's going to give you an undefined value. And that would be an example of something that would not be a valid output for y. Another example would be if you end up with something like when after you plug in x, like the square root of -8. Okay. -8 is going to give us a complex number, which we've worked with before, but when we're talking about a valid output, we're talking about all of the real numbers that you could get for your y. So in here, we also want to try to avoid getting complex or imaginary numbers. So the two things you kind of want to watch for are when you're working with any sort of function, the equation of a function, you're looking for things that like if you have a fraction, if there's a variable in the denominator, that could potentially lead to that problem with divide by 0. And you're also looking for if you have any radicals that have variables in them, which could potentially lead to having an imaginary number underneath the radical. So let's look at a few examples. So for this function, f of x, we have 9 over x cubed minus 36x. So in this case, we have the potential to divide by 0 on this function depending on what x is because there's x in the denominator. So basically what we want to do, we want to figure out what will make that denominator equal 0 and then exclude those specific x values. So we're going to kind of do x cubed minus 36x equals 0 off to the side. Now when you look at that, they both have an x in common, so you can factor out an x. So we have x squared minus 36. And then we can also factor the x squared minus 36. Once you get the equation factored, then you take each factor and set it equal to 0. So x plus 6 equals 0. X minus 6 equals 0, and solve for x for each of them. So for this first one, x is already solved for. The second one, x would equal -6, and for the third one, x would equal +6. So these three values, 0, -6, and +6, all three of them would cause you to have an undefined value in your denominator. So for example, if I choose one of them, the -6, for example, just to show you, if I take -6 and I plug it into the original function, and then we simplify, so you'd have 9 over -6 cubed is -216, and then -36 times -6 would give you a +216. So when you simplify that, that would give you 9 over 0, which is an undefined value. So what that means is if you were to graph this original function, so 9 over x cubed minus 36, and look at the table, you would see that there's no y coordinate in the table that corresponds to that given x value. And actually what you would see in the table would be just a bunch of errors where those x values are. So how we're going to write our domain, and you can do this for, and really we could double check this with all the values, but all of them when you plug it in are going to give you that 0 in the denominator. So your domain in set notation is going to be, let's see here, domain. So set notation is where you use the curly brackets, x such that x is in the set of all real numbers. So every single real number is going to be valid for the domain except for these three. So how we're going to say that, so x is in the set of all real numbers, but we're going to exclude, so x can't equal 0, x can't equal 6, and x cannot equal -6. And that's how you would write the domain for this function. Again, always double check it by graphing and look at the table and see kind of where you have those errors in your table, and that should help you out. Let's look at an example of one that has a radical sign in it. right, so if you take a look at the function g of x, we have the square root of x minus 6 divided by 2x. Now, in this case, we have two potential problems. Here, we have the potential to divide by 0 in the denominator, so we need to figure out what makes that denominator equal 0 and exclude that value. So we can kind of do that quick off to the side. So we're going to have to exclude 0, depending on what the numerator is. So now, up top, we have x minus 6 underneath the radical. So we want this radical to stay positive. So we set it greater than or equal to 0. And you can kind of just solve that off to the side as well. I don't include the radical sign. I mean, if you do, just watch what happens. If you include that radical sign, it's not wrong if you do. But if you include it and then you go to solve it, to solve for x, the first thing you're going to have to do is square both sides. So you're going to be left with x minus 6 is greater than or equal to 0 anyways. So that's why I usually don't include the radical when I set this up. So if you continue solving for x, we get x is greater than or equal to 6. So what we're left with, x is supposed to be greater than or equal to 6, and we're also supposed to exclude 0. However, if we're stating that x has to be greater than or equal to 6, it goes well with well, not goes well with, but we don't need to include this because by saying x is greater than or equal to 6, we're already saying, nah, it can't be 0 because that's less than 6. So that would be our domain. To kind of show you why a different number wouldn't work. So if I pick a number that's less than 6, so let's say 4, and I plug it in. If I plug in 4, I'd have the square root of 4 minus 6 over 2 times 4. So in the numerator, you'd get the square root of negative 2 over 8, which would give us I radical 2 over 8. That's not a real number, so that's why we can't include those kind of numbers in our domain. If you go to graph this function, you would see that there's a whole bunch of numbers that there are errors for in your table, and it's going to be anything that's less than 6. So your domain here, set of x such that x is in the set of all real numbers, only the ones that are greater than or equal to 6. I should mention you could also write this in interval notation. Interval notation is kind of where you use the number line and the square brackets or the round brackets, or the round parentheses rather. So just to I like to kind of draw the number line to help me out a little bit. If it's greater than or equal to 6, you'd have a closed dot at 6, and greater than would shade to the right. Interval notation then would be 6 with the square bracket, because that's the lowest number x could be. And since that shades off the positive end to positive infinity, that would be another example of how you can write your domain. Again, this is interval notation, and this is set notation. And really, either one is acceptable, but you need to make sure that you're comfortable with both. Let's take a look at another function. All right, here we have h of x is equal to 2x minus 9 all over 5. And here, if you think, again, you're trying to avoid imaginary numbers, so taking the square root of a negative number. And if you look at this function, there is no radical sign, so there's no way we're going to end up getting an imaginary number for any value of x that we plug in. The other thing we want to avoid is dividing by 0. Well, if you look at the denominator right now is just 5. So no matter what number we put in for x is only going to affect the numerator. And the numerator can be any number, any real number. So no matter what we plug in, the denominator is going to continue to stay positive 5. So we're not going to run the risk of dividing by 0 for this. So in this case, since there's no radical with an x underneath of it, and there's no variable in the denominator, this will be a case where your domain is just all real numbers. And if you wanted to write that in interval notation, it would be negative infinity to positive infinity. So whenever these two things are true, if there's no radical, the variable underneath it, no variable in denominator, you can just go ahead and assume that the domain is all real numbers. And you can double check by looking at the table as well when you graph it in your calculator. As you'll see, there'll be no errors in the table, and even if you look at the graph, there'd be no gaps in your graph. This would be a continuous line. So there's no x values that you would need to exclude. Let's take a look at one more. So we have the function k of x is equal to 5x divided by the square root of 4x minus 16. So for this one, we have kind of two things that could happen here. Here, since we have a fraction and there's a variable in the denominator, we want to avoid dividing by 0. So we don't want the denominator to equal 0, but in this case we also want to avoid taking the square root of a negative number. So we can combat both at the same time by saying that this, the square root of 4x minus 16, we only want it to be greater than 0. So by saying that that radical is greater than 0, we're going to ensure that what's underneath the radical stays positive, and we're also going to ensure that it's not going to divide by 0 because we didn't put that extra, we did not use the greater than or equal to 2 sign, because that would imply that it was allowed to equal 0, and that's what we're trying to avoid on this one. So if we go ahead and solve this, 4x minus 16 greater than 0, so 4x is greater than 16, divide by 4, so we end up with x is greater than 4. So if we were to write that in interval notation, it'd be from 4 to infinity. But since 4 is not included, it's not allowed to equal 4, we're going to put a round parenthesis around the 4. Just to kind of show you that, had you made the mistake of saying that it could equal 4, so if you had said on accident that x was greater than or equal to 4, if you plug in 4, 5 times 4 up top, the square root of 4 times 4 minus 16, you get a 20 in your numerator, and then 16 minus 16 in the denominator, so square root of 0, and it's undefined. No good. So that's why we don't include 4. But anything bigger than 4, fair game. So your domain for that one is x is greater than 4, or in interval notation, 4 to infinity.
Made with Doodlecast Pro.